ago, scientists believed that volcanoes were burning mountains of fire. Today we know volcanoes are openings or vents to the hot interior of the planet. On today's TED Talk, we're talking about different types of volcanoes, demonstration of volcanic eruptions, and the different physics of a volcano.
Before we picked our topic, there was many to consider, such as happiness, heartbreak, sadness, jealousy, anger, affection, grief, fear, love, deafness, and natural disasters such as tornadoes, hurricanes, and the physics of rainbows, sound waves, disorders, brains, or speech. But we ended up picking volcanoes. We considered all the other options, but volcanoes were the most informative topic and related to physics the best. And we don't live in an area where volcanoes are seen or experienced, so it was interesting to learn about them.
In today's experiment, we are creating two types of different volcanic eruptions with these model volcanoes. These lava domes, which is just a fancy word for passive rock made from lava, will help me show you volcanic eruptions. The first kind of eruption I will show you is a strombolian eruption, which are just bursts of lava from the mouth of the volcano. I will be using Mentos and Diet Coke to show you these. The first kind of volcanic eruption I'm going to show you is a strombolian eruption. So with this, I'm just going to use the 2-liter pop and then some Mentos. So let me just pop the Mentos in there. The second kind of volcanic eruption I'm going to show you are Volcanian eruptions, which are just short, violent, small explosions of magma out of the spout of the volcano. I will be using baking soda and vinegar to show you this. The second volcanic eruption I'm going to show you is the Volcanian eruption. First, I'm going to just add a little bit of vinegar to the spout, and then I'm going to add the baking soda as well. Just get it there. And there you go. Volcanoes are a lot more complex than people may think. Volcanoes actually have a purpose. They're not just piles of rocks sitting on Earth doing nothing. Volcanoes are vents that are linked to the Earth's core, but they sit on the Earth's surface. So when the Earth's core wants to get rid of something, it just goes up. There are many aspects of physics in a volcano. For example, the plate tectonic theory, or better known as the continental drift, plays a big role in volcanoes. For example, it plays a role in how the volcano is formed, so how it looks to other people, and how the volcano erupts, and how powerful the eruption is. Another example is the viscosity of the magma and lava and how the volcano actually erupts. Examples explained. The plate tectonic theory is what scientists call the tectonic plates that are moving below Earth's surface. The movement of these plates can cause a lot of things, like natural disasters, for example, like earthquakes and, you guessed it, volcanoes. The tectonic plates are located all over the world. However, the major ones that most scientists look up are the ones on the edges of the continents due to the continental drift theory. These plates can move horizontally, vertically, and closer and farther apart no matter the time and no matter the place. Over the years, the tectonic plates have been moving farther and farther away from each other. Therefore, the continents have been moving farther and farther away from each other also. Hence, the continental drift theory, which is just the theory that the tectonic plates, are moving the continents as well. The most active plate movement is in the basin of the Pacific Ocean, known as the Ring of Fire. The Ring of Fire has about 452 volcanoes. 50% of these are active, which means that the volcano can and will erupt very soon and has in the past. A dormant volcano means that it hasn't erupted lately, but in the near future there is a possibility that it can. The plate movement plays a very important role in how a volcano is going to look. If a volcano is or was on a very active plate, then the volcano is going to look more like a cone. This is due to the numerous eruptions that the volcano has had because the lava has went over the sides and dried up, which made many layers which formed a cone shape. Therefore, if a volcano is on very inactive plates, then the volcano is going to have more of a crater shape to it. This is due to the lack of lava buildup over the years. All in all, if a plate moves a lot, then the volcano eruption is going to be greater, and if a plate moves a little, then the volcano eruption is going to be little. When describing the physics of a volcano, a very important word keeps coming up. That word is viscosity. By definition, viscosity is the internal resistance to a flow by a substance when a shear stress is applied. So practically, in simpler terms, viscosity is a fluid's, in this case the magma's, resistance to flow, in this case out of the volcano. Just so you know, magma is a liquid inside the volcano, while lava is a liquid rock, which is magma coming out of the volcano. Anyways, due to the fact that each eruption differs from one another, that means the viscosity in each eruption is going to differ also. However, even though no two eruptions are exactly the same, they could be very similar to one another, so each kind of eruption can be categorized in one of four: the Plinian or Vesuvian, the Strombolian, the Hawaiian, or the Volcanian. Plinian or Vesuvian eruptions look like just a gas just being ejected into the air with ash. It looks like a very heavy smoke. These kind of eruptions can last for hours or even days. Due to this, scientists have determined that the viscosity of the magma for this kind of eruption is very high considering the time lapse. If you can't imagine this kind of eruption or picture it in your head, just kind of picture Pompeii, because this is the kind of eruption that buried it. A Hawaiian eruption occurs when the lava ejects from the vent of the volcano. For this kind of eruption, there's generally two kinds of outcomes, so the viscosity is going to vary depending on what kind of outcome you have. One is called a fire fountain, which is when lava just goes into the air and it's sprayed into the air from the volcano. Generally, the viscosity for this is very low considering that's a very fast-paced kind of eruption. The second kind is called lava lakes. That's when the lava just slides down the volcano very slowly and gently, so therefore the viscosity is going to be very high considering that it's a very time-consuming process. In the experiment I conducted, I did a Strombolian eruption, so you guys should already have a picture of that in your mind. Just to refresh your memory, it is kind of just bursts of lava out of the spout of the volcano. Therefore, the viscosity is going to be very low considering it's a very fast-paced movement. In my experiment, I also did a Volcanian eruption, so you guys should have that kind of pictured in your mind as well. But just to refresh your memory again, a Volcanian eruption are short, violent, small bursts of lava just gliding down the side of the volcano. Therefore, the viscosity is going to be very low since it is a violent, short burst.
Warning, this is not my real voice. I'm just sick, so this is what it's gonna be. First off, not everyone is going to be a geologist. Not everyone is going to be a volcanologist. Not everyone will live near a populated volcano area. Not everyone is interested in the vent that spews hot lava. So you may be wondering why all this information on volcanoes concerns you. Well, I'm here to tell you just that. There are volcanoes that are still active, meaning they will erupt in the future. They will erupt in the future. As our population increases, areas near volcanoes will be made available for future homes. Therefore, volcano eruptions are still a future risk for hundreds of thousands of people. Alarmed. The U.S. Geological Survey and its partners monitor volcanoes in order to issue any warning of any harm. Their job is to keep U.S. communities safe from volcano hazards that can destroy their homes, towns, transportation routes, or means of communication. Essentially, their job is to monitor volcanoes and enforce emergency response when needed to save lives.
If this wasn't enough to convince you on why volcanoes are important, then open your eyes. Take into the fact that there is more to this world than just where you are. There are other states, other countries that are being affected by tragedies every day. Every single day. The earth is an abundant place filled with beauty and opportunity, but there are natural disasters that could cause an end to all of that. Take notice in the things around you. Educate yourself on the things that you don't. Volcanoes are just one of the many tragedies that not many people take notice of. Tune in next week when we explore what happens when tectonic plates slide past each other, when energy is released in different directions, when the ground beneath your feet shakes. Earthquakes. You won't want this one to slip away.